As if on cue, mainstream media jumped at the chance to blame so-called man-made climate change for the recent outbreak of tornadoes in the Mid-South, especially the one that devastated so much of Mayfield, Kentucky. They blamed that on climate change. Common was the claim that a warmer world means more and stronger tornadoes. Ecologist Jim Steele, author of the book Landscapes and Cycles, An Environmentalist's Journey to Climate Skepticism, decimates that claim in a recent short video. He and I will discuss the tornadoes, their real cause, the media's twisting of science related to them, and his book on tonight's program. So stick with us, and I think you'll have a wonderful time. My name is Cal Beisner. I'm the president, the founder, and national spokesman of the Cornwall Alliance for the Stewardship of Creation. And welcome to From the Stacks. Our aim, our ministry with the Cornwall Alliance, is to educate the public and policymakers on biblical earth stewardship, economic development for the very poor around the world, and the gospel of Jesus Christ, together with the worldview, the theology, and the ethics that come with that. And it's our privilege, it's our delight to be able to work in these fields. Every month, we offer, as a way of saying thank you, when people make donations of any size, 100% tax deductible, a special educational resource. For the month of December, that's right up to midnight on December 31, we're offering to send the DVD of The Riot and the Dance, Earth, a marvelous nature documentary that, that glorifies God and points to God as the wise creator and sustainer of all of his creation. To request your copy, just simply go to cornwallalliance.org. That's cornwallalliance.org. Click on the donate button, and as you fill out the donation form online, you'll come to a comments field, and there write in promo 2112 or promo code 2112 or the title, The Riot and the Dance. And we'll be glad to send you a free copy of The Riot and the Dance, Earth, marvelous nature documentary. Now, time to bring on our guest, Jim Steele. And Jim, thanks very, very much for joining us this evening from out there in California. You live fairly near San Francisco, right?
Right, just south in Pacifica.
Yeah. And tell us about yourself a little bit. I think it's much more interesting when people hear from my guest than just to hear me tell a little bit of a sort of a dry biographical background. So how did you get into all of this? What have you been doing with yourself for the last 40 years or so as a scholar? And how did you get
I'm
so
not going to tell you
particularly
everything I've been doing, but
not everything.
I'm an ecologist, and I was hired by San Francisco State University to be director of the Sierra Nevada Field Campus, which is about an hour north of Lake Tahoe, and studying wildlife and why wildlife changes were happening. And in California, to do that, you really become sensitive to El Ninos that might bring heavy snowfall and push populations downslope, or it might bring a La Nina and a drought that dries things up, pushes populations upslope. So not only did I have to learn the biology and the botany and the geology, I had to start really understanding how the climate works and how the weather works and what are these natural cycles that happen. And part of my job also with the field station was to educate people about the environment. How does nature work? And I've been a long time avid environmentalist, and I brought in some of the best people we know to teach about this. And just as I progressed with my understanding, I became a strong skeptic of this climate change stuff, because I would see so many different things happening that you could explain all of it based on natural cycles like El Ninos and La Ninas, and there's others, and the way people have changed the landscape, which has caused problems. And those things we definitely need to fix. But I don't see CO2 or climate change being the big. It's a minor change, and a big thing this year was wildfires. And we got to limit CO2 or we're going to have more burning. Well, nothing could be further from the truth. That's the least of people's problems. If you got rid of CO2, you're still going to have wildfires because you didn't manage the forest right. So I've just felt for the last, and I published the book in 2013, I needed to want people to understand what are the factors that are causing things, the things that we can fix, and the things that we have to just accept and learn to adapt to, the natural cycles. Okay, I couldn't hear you for a second.
Yeah, we have your book on landscapes and cycles in the online store of the Cornwall Alliance. And so I would encourage people to visit that. Just go to cornwallalliance.org/shop, and you'll be able to find Landscapes and Cycles, an environmentalist's journey to climate skepticism. I think that subtitle is particularly important for people to recognize, because Jim is nothing if he is not who cares about the environment, who cares very much about making sure that we don't ruin good ecosystems. And that would have, predisposed him to embrace the sort of climate alarmist narrative. But what he did was he really dug into all the evidence, and he decided that it just doesn't support the notion that human emissions of CO2 and other greenhouse gases are causing dangerous to catastrophic global warming, as opposed to simply contributing in a fairly benign way to warming that is likely at least partly natural. So, yeah, Jim, thank you so much for doing that book. I found it fascinating to read, and so have many other people who've gotten it from Cornwall Alliance. We used that as a gift to donors about about a year and a half, 2 years ago. Had very good response to that. This evening, though, we're focusing particularly on the claim that man-made climate change has caused more and stronger tornadoes, and and particularly that it contributed to the outbreak of tornadoes a couple of weeks ago in the Mid-South, especially the terrible one that just devastated Mayfield, Kentucky, causing huge tragedy there and great loss of life. Of course, our hearts go out to the people there. We pray for them. We ask for the Lord's mercy and a rapid recovery from all of that damage. And especially, we hope that many of those who lost their lives knew Christ, and thus, frankly, went into greater joy than they've ever known before when they died. But certainly those who are left behind have to struggle with grief. But the claim that climate change or man-made global warming drove those tornadoes, caused the outbreak of them, caused that one to be so strong, and so on. That claim really deserves careful evaluation, and that's exactly what Jim Steele has given it in a wonderful video that he prepared. And so we would like, at this point, well, before we actually show that, Jim, just tell us how it came about that you decided to do the video itself.
I've been doing a series of videos on different issues as they pop up. In terms of the tornado, again, I saw, President Biden and the typical alarmists like Michael Mann come out and say, oh, this is all due to global warming. And one thing I was familiar with earlier, well, a couple of things, but if you look at the National Weather Service looking at tornadoes in Georgia, the warmest months, July, August, September, have the fewest amount of tornadoes. So it's not this warm temperature that drives it. Now, what it is an interaction between warm, moist air and cold, dry air. And it's the moisture and the dryness that are really the key drivers. And in understanding how the weather and the climate worked in the Sierra Nevada, that I was very familiar with. And so I went on to a website that I could see how the temperatures, how the humidity, and all these factors were coming about. And in looking at those, it clearly showed that what you had was humidity being driven in from the Gulf of Mexico up the Mississippi River Valley, and then coming from the west, my part of the country, and partly due to La Nina, you have these very dry, cold air coming across the Rocky Mountains. And when that happens, this warm moisture just gets this energy as it can stay warmer than the air above it and just rise and make a very powerful storm. Um, so that's what prompted me to do that. So that's why I try to show people it was this moist air coming in, the dry air, and the way the winds are. The winds give it a little extra spin to help it. And so you get these thunderstorms, and they're not, you don't always get a tornado from a super thunderstorm, but you have these severe thunderstorms that create the tornadoes. So that's what
Yeah.
said, well, I got to put this out for whoever's listening, because there's too much. The media likes clickbait crises to get people to
Right.
kind of click on what they have, and it was just wrong.
Yeah, right. As Dr. Roy Spencer, who's a senior fellow and board member with the Cornwall Alliance, puts it, and he has done a great deal of work on tornadoes. Warm and cold air together don't guarantee tornadoes, but you can't get them without it. and,
Right.
And that's difference between a necessary cause and a sufficient cause. So let's go ahead now and show our viewers the actual video itself that you made. And after that, we'll make some comments on that. And following that, you have a much more recent one that goes into more detail on some of the factors that are indispensable to the formation of tornadoes and what's been going on with those during the period of recognizable global warming. So can we get that started now, producer?
The heart-wrenching devastation in Kentucky and the surrounding regions due to several tornadoes has caught everyone's attention. Fortunately, meteorologists have been increasingly capable of issuing tornado warnings and have greatly reduced tornadoes-related death tolls. But despite adequate warning, one tornado took direct aim on Mayfield, Kentucky, causing buildings to collapse and a horrible death toll. The USA experiences more tornadoes than elsewhere, suffering over 1,100 tornadoes a year. This is due to the mountain configurations that funnel cold, dry Arctic air southward to collide with warm, moist air from the Gulf of Mexico moving northward. Tornadoes are most common in the spring as solar warming drives warmer air northwards to collide with the retreating cold winter air. Although rare in the winter, tornadoes also happen in the winter. Disturbingly, every disaster brings out the ambulance chasers, hoping to profit from tragedy. As has become all too common, the ambulance chasing climate journalists wasted no time trying to attribute climate change to this catastrophe, as seen by the Associated Press story that is now circulating in many outlets. Despite most scientists admitting that attribution of tornadoes to climate change is extremely difficult, the AP journalists tried to force a connection with statements like, well, warm weather was a critical ingredient in the tornado outbreak, and the standard blather that extreme storms are becoming more common because we have a lot warmer air masses in the cool season that can support these types of severe weather outbreaks. But the science does not support such narratives. As seen in the illustration, both cold and warm air is required. Tornadoes develop when the atmosphere becomes unstable, as cold, dry air overlays warm, moist air. These conditions will then promote columns of intensely rising air. In addition, tornado formation requires spin, caused by winds from various directions, called wind shear, imparting rotation. I noticed all those tornado promoting conditions were developing the day before, so I am sure weather forecasters did too. Here are screenshots from the website Earth Null School, a site I highly recommend everyone who is interested in understanding weather and climate. I roughly overlaid a map of the American states to help visualize the approximate locations of tornadoes, and the green circle here identifies the location of Mayfield, Kentucky. This screenshot shows cold air in the blue colors coming from the west and the Arctic, colliding with warm air, the orange color, intruding from the Gulf of Mexico. Temperatures in the Gulf of Mexico are just average, so the intruding warm air is not unusually warm, but it does raise Mayfield, Kentucky temperatures to about 70 degrees Fahrenheit. However, what has been unusual is the colder temperatures over the Great Plains. The white lines in this screenshot represent the surface winds. The brighter the white, the stronger the winds. On the website, those winds are animated. So I have added red arrows to show wind directions. With temperatures around southeastern Kansas at about 40 degrees, winds from the northwest are cold, colliding with warm air from the south, creating lift and spin that's needed to spawn winter tornadoes. This screenshot is taken from the exact same time, but with an overlay of the atmosphere's total precipitable water. The cold air to the west and the north is very dry, the brown color. The warm air intruding from the Gulf of Mexico is very moist, the blue color. Thus, all the conditions to spawn winter tornadoes are in place throughout the Mississippi River Valley. It is also well established that a dip in the jet stream as cold air pushes southwards is associated with extreme weather events and tornadoes. At the bottom of the trough, wind speeds are slower, but the speeds increase as the winds exit the trough to the east. This increase in upper level wind speed promotes a stronger lower pressure zone at the surface that intensifies cyclones and tornadoes. Accordingly, this screenshot of the upper level winds at about 500 hectopascals, approximately 800 feet above sea level, shows an upper level trough forming to the west of Kentucky. The town of Mayfield is situated directly below the region where the jet stream is increasing speed and intensifying storms. So why did these conditions develop? Well, one piece of the puzzle is the location of the Bermuda high pressure system and its clockwise circulation of winds. The Bermuda high is a key factor affecting tropical weather, as well as how much warm, moist air gets pumped into the eastern USA. Scientists compare the ever-changing position and strength of the Bermuda high to the motion of a cork in a bathtub. Various waves and disturbances shift its location, making weather predictability very difficult, never mind determining any climate trends. When located further east in the Atlantic, droughts in the Midwest and even eastern USA can happen. The further west the Bermuda highs are located, the greater the amount of warm, moist air gets pumped into the USA. Now, one factor affecting the location of the Bermuda high is the natural North Atlantic Oscillation, which can change its phase from month to month. When the North Atlantic Oscillation is in its positive phase, pressure increases as well as the strength of the trade winds, and that pushes the Bermuda high further westward. So the North Atlantic Oscillation is used in weather forecasting. While recently bouncing between positive and negative phases, scientists had predicted the North Atlantic Oscillation would remain in its positive phase through mid-December 2021. And as a result, moist air was indeed pushed up the Mississippi River Valley in the winter, supplying the key ingredients that spawned the deadly tornadoes in Kentucky. The mainstream media's exploitation of this tragedy is another disturbing example of ambulance-chasing climate change journalists failing to inform the public about natural extreme weather events. Just as I finished crafting this presentation, I see Dr. Roy Spencer published an article on how increasing cold weather increases tornadoes. In terms of departures from normal, so far this year in the Northern Plains has been one of the coldest places, as average temperatures are 5 to 10 degrees below normal. Spencer also posted this graph showing the declining trend in violent tornadoes, again refuting the idea that global warming is related to any increase in destructive tornadoes. Choosing to fearmonger a bogus climate crisis narrative is so disgustingly shameful. But sadly, President Biden, despite lacking any scientific knowledge, joined the fearmonger, saying, "The intensity of the weather across the board has some impact as a consequence of the warming of the planet and climate change. The fact is that we all know, really, everything is more intense when the climate is warming everything. And obviously, it has some impact here." Really, Joe? So up next, I still plan several short educational videos discussing how naturally varying locations and intensities of atmospheric pressure systems are the control knob that control climate. So people can gain an understanding of what determines climate and severe weather events. Although not intending to start with the effect on tornadoes, this tragedy prompted the first of several of more in that series. And until then, embrace renowned scientist Thomas Huxley's advice that skepticism is the highest of duties and blind faith the one unpardonable sin. And if you appreciate the science clearly presented here, science rarely presented by mainstream media, then please give it a like, give it a share, or copy the video's URL and email it to your friends. Subscribe to my channel to see all the videos I've been presenting, or read my book, Landscapes and Cycles, An Environmentalist's Journey to Climate Skepticism. Thank you.
So that was your first video on the tornadoes there. I would mention one thing in your transcript of that, which you had on your own website, whereas that video we just showed from whatsupwiththat.com. In your transcript of that, you pointed out that the 500 hectopascals was equivalent to about 18,000 feet in altitude, whereas as you were speaking there, you said 800 feet. And just a slip of the tongue, just want to make sure that nobody...
I've done that a couple of times, and I'm a little embarrassed, but I try to correct it with the transcripts. And
yeah, which one of us has never done a slip of the tongue? Certainly not yours truly.
Often, but
not yours
I
truly.
blame old age.
So, what sort of reaction have you had to that? I know, What's Up With That is an extremely well-visited website, and your own site, I'm sure, gets its own good traffic. How have people responded generally?
It's hard to completely judge. I know some people say, I really appreciate the videos. Others say, I'd rather have a transcript, so that's why I've been trying to do both for people. And I've pretty much had about 1,000 views on the video and close to 1,000 views of the transcripts. I'd link to my Twitter account, but Twitter has sort of been pushing me down the news feed, so I don't get a lot of... I used to get hundreds to thousands of views when I would do something on Twitter. Now I'm lucky if I get 40 or 50. And and they're known, and they admit that what their fact checkers do, if they disagree with you, they move you down the news feed, so people don't view what you're doing. So I don't know how it's being spread in different domains, but What's Up With That? I'm sure a lot of people see it. I don't know how many people view it versus how many people comment on it. So it's, but it is at least a few thousand people, I'm sure, have seen it.
Well, that's good. I know when I watched it, I just said to myself, this is a really clear and comprehensible explanation of how tornadoes form and why, particularly in that period, that just a few days' time, there were just the perfect conditions to form those tornadoes. And it didn't depend on having higher than normal temperatures. In fact, it depended on having colder than normal air coming into the region from the west and then colliding with the actually the warm, moist air coming up from the Gulf, pushed, as you said, by the Bermuda High. So this is something that, frankly, most meteorologists ought to understand very well. The problem is that too many journalists really just don't, and they're trying to work quickly and, frankly, don't find these things out.
And I would say the most powerful driving force on these is the collision of moist air and dry air. With moisture, for water to evaporate, it takes a whole lot more energy. And when it rises, it cools and it releases that heat, which keeps it warmer and keeps it rising. And it will rise right up to the stratosphere. I don't know how many people have seen the anvil clouds of a thunderstorm, but you see these clouds rise to the sky and then flatten out. And why they call it the stratosphere is from the beginning, the end of our troposphere to the stratosphere, it starts warming. And so the air that's rising all of a sudden can't rise any higher because the air above it is warmer. So it's really the moisture that allows these windstorms to rise and create these extreme storms, whether it's a thunderstorm, a hurricane, or a tornado. So that's why I try to push in the next video of what is this we call convective energy, how much is driven by this difference in humid air and dry air. And all the trends show, for the latest research, it shows that these severe thunderstorms, this amount of convective energy has been getting far less over the last 40 years. And so it completely contradicts what everybody's saying, global warming is going to cause more storms. It's just not happening.
Yeah, I know quite a number of the different journalistic treatments after that outbreak of tornadoes a couple of weeks ago really tried to push the idea that, well, after all, we have more tornadoes reported over the last 40 years than we did over the previous 50 years or so. And what they don't tell you is that the reason we're reporting so many more tornadoes is not that there are more, but that our observational technology has improved drastically. I mean, we brought Doppler radar really into play right around about 1990, and that's when you see the increase in the numbers, but you don't see an increase in the strength, and in fact, you see a decrease in the number of major severe tornadoes, F3 and F4, over that period. Well, you mentioned that you did this second video, and let's go ahead and see that one. This is one actually that I haven't seen. You just mentioned it in the few minutes before we went live tonight. So I'm eager to see this because it provides an explanation for precisely why the folks who are saying that global warming will cause more frequent and more powerful storms, including tornadoes, are mistaken.
Welcome back and happy holidays. Today is part one on how pressure systems control climate change and the decline in extreme weather. So I'm delving into the new scientific research that contradicts climate crisis claims that global warming is causing more extreme weather by increasing the convective energy that enables tornadoes, hurricanes, and thunderstorms. In response to public questioning of how global warming could possibly cause both floods and droughts, scientists who were obsessed with a climate crisis pushed a very simplistic meme that the wet regions will get wetter and the dry regions will get drier. But unlike the absurd claims that rising CO2 is causing everything from more wars and prostitution to more wildfires and higher divorce rates and albatrosses, Their wet gets wetter and dry gets drier meme has some basis in reality. Scientists studying clouds on a microscale of, say, 5 kilometers report that convection is in part initiated by solar heated surfaces that contact the air, making the air warmer, less dense, and more buoyant, causing it to rise, while being replaced by cold downdrafts. The exact same dynamics are at work on larger scales. The Hadley circulation cell covers 7,000 kilometers, is driven by intense solar heating around the equator, resulting in an area of low pressure with rising moist air. That air cools and condenses as it rises, resulting in the Earth's heaviest rainfall. What goes up must come down, and having lost its moisture while rising, regions of dry sinking air happen a few thousand kilometers to the north and the south, creating large areas of exceptional dryness beneath high-pressure systems. Therefore, assuming rising CO2 is warming the planet, it then seemed logical to believe a warming planet would increase convection and increase rainmaking while increasing the sinking air elsewhere that fosters dryness. So their models were constructed accordingly. The problem is observations do not support their CO2 connection. Here I simultaneously present two views of the Earth's major circulation patterns and resulting pressure systems. The upper panel shows a cross-section of the Northern Hemisphere. This lower illustration shows the average position of quasi-permanent pressure systems across the globe, here in the month of January. So here I just focus on the pressure systems most implicated in the wet gets wet and the dry gets drier narrative. Other pressure systems are discussed in other videos. The rise in convection at the equator results in a global belt of low pressure known as the Intertropical Convergence Zone, or ITCZ, and represented by the dashed red line. And that generates the tropical rainforest ecosystems. The descending air happens about 30 degrees poleward of the equator and is focused over the oceans, and it can reduce the transport of moisture, which results in the Earth's greatest desert regions. Recent results from an international team of scientists, referred to here as Tazarek et al. 2021, examined trends in global rainfall based on observational data in the European Center for Medium-Range Weather Forecasts Global Reanalysis Model from 1979 to 2019. Their research results suggested just the opposite of what global crisis warming theory predicts. On average, the Earth is experiencing declining convective energy and thus declining extreme storms and rainfall. The wettest regions are getting drier. This research was not trumpeted by the mainstream media because it did not promote that clickbait climate crisis that the media seeks to profit from. Now, this map from their results illustrates the Earth's regions with the greatest precipitation. As expected from the Hadley circulation, the regions of the greatest annual rainfall exist in the low-pressure ITCZ regions around the equator, supporting the tropical rainforest ecosystems of the Amazon, Central Africa, and the Southeast Asia's maritime continent, consisting of Indonesia, Malaysia, Borneo, and the Philippines, and the seas of the Coral Triangle, all colored here in red. Areas in green to white are low rainfall areas beneath dry, high-pressure areas in the subtropics. The trends from precipitation data suggest those wettest areas are getting drier, as seen here represented in blue. Significant drying is showing with hatch marks, suggesting a decrease in evaporation, which is contrary to global warming models. There are also some non-significant wetter regions illustrated in light yellow, but dry areas show very little increase in rainfall. Now, convective storms producing hurricanes, tornadoes, heavy rain, hail, and lightning are most destructive. So to better predict these storms, scientists track changes in CAPE, C-A-P-E, which is abbreviations for Convection Available Potential Energy. CAPE is driven by the warmer and moister conditions of an air mass relative to its surroundings. As would be expected, the greatest annually averaged amount of potential energy for convection coincides with the warm, moist regions of the ITCZ where the greatest rainfall is observed. But again, contrary to climate crisis predictions, the energy for convection in more extreme storms has declined for most regions. Now, the cause for high potential energy outside the tropics, over the USA's Great Plains and southern Europe, requires some additional explanation. The high CAPE is partially driven by the result of warm, moist air lying below dry air. Dry air that's due to its crossing the western USA mountains or arriving from the Sahara Desert. Air freely rises only if it's warmer than its surroundings. Warm smoke from a chimney in the winter rises at first, but suddenly hits a glass ceiling and goes sideways. This is because the air above is warmer than the smoke. Now, during the winter, the land cools much faster than the air above, so the lowest atmospheric layer, the boundary layer, is colder than the air above, and this is referred to as an inversion layer. The smoke mixes with the colder air and no longer becomes warmer than the air above. The question then arises, if the smoke here doesn't rise much higher than 1,000 feet, how can warm air in the tropics rise to 1,400 kilometers? Well, the answer has to do with the interaction of moist air with dry air. As known from the gas laws, dry air temperature drops by 10 degrees centigrade for every 1,000 meters it rises, solely due to the decrease in air pressure, referred to as adiabatic cooling. For example, air on the surface at 10 degrees centigrade or 50 degrees Fahrenheit cools to minus 20 degrees Fahrenheit, minus 4 degrees Fahrenheit, after rising 3,000 meters. Likewise, rising smoke was also cooled adiabatically. However, moist air does not cool so rapidly. As moist air rises and cools, it reaches a temperature that causes water vapor to saturate and convert to liquid rain. That releases the extra heat the water vapor acquired during evaporation. That released heat energy causes rising moist air to cool much more slowly than the surrounding dry air. Moist air cools at a rate of just 6 degrees centigrade for every 1,000 meters of altitude. It is the release of heat from water vapor that allows moist air in the tropics to remain warmer than its surroundings and allows rising air currents to reach 14,000 kilometers in altitude, as well as providing more convective energy. Thus, warm, moist air rising in an environment of dry, cold air increases convective potential energy and enables more thunderstorms and tornadoes and in the USA's greatest plains in the southern USA. Accordingly, TASAREC 2021 found the highest frequency of thunderstorms in the warm, moist tropics, but also reported a relatively high rate in the eastern USA. This is because the Pacific high-pressure system reduces moisture flowing from the ocean over the western USA. The eastward moving air is further dried as it passes over the western mountains. After passing over the Rocky Mountains, the resulting dry air often rides above the warm, humid air being pushed into the Great Plains in eastern USA by the Atlantic high-pressure system. And that sets the stage for intensive convective thunderstorms and tornadoes. Yet despite the global warming crisis narrative, that global warming increases humidity and increases convective energy, and thus intensifies storms, thunderstorm frequency around the world, except for over India, has been declining. Now, some of the most severe thunderstorms happen in regions where that dry air is moving eastward across mountain ranges and interacting with moist air, causing the greatest duration of the most severe thunderstorms. Yet again, in contrast to climate crises narratives, most of those regions have experienced fewer severe storms. Now, this might seem counterintuitive only because the mainstream media and politicians pushing a climate crisis try to focus the public's attention on any destructive storms that naturally happen, and dishonestly suggest it was more likely due to climate change. The scientifically documented decrease in convective potential energy in thunderstorms correlates with the decreasing trends in severe USA tornadoes. Despite that data, the chief climate alarmist and digital book burner, the Joseph Goebbels of climate change, Michael Mann, has been the media's go-to person for clickbait climate crises narratives. In an interview with the USA Today, he falsely said that the latest scientific evidence indicates that we can expect more of these huge tornado outbreaks because of human-caused climate change. And to push that alarmist narrative, Mann tweeted the graphs from AEI shown here, showing declining intense tornadoes, was just denialist propaganda. But the graphs is just an extension of the very same declining trend that NOAA had produced until 2014. What NOAA likes to now show are graphs of total counts, and 75% of that count are due to very weak tornadoes that often escaped detection in the past. Total counts had suggested the same declining trend from the 70s to the 80s as the trend in declining counts of severe tornadoes. The sharp increase since the 1980s was the result of the Weather Service employing more storm spotters, which added more very weak tornadoes to the count. According to a NOAA research paper, detection probability since 1987 increased from 30% to 70%, so that increase in counts is simply a detection effect. And despite increased detection, total counts have declined over the past 2 decades. So trust the science, not the alarmist media and wayward scientists like Michael Mann. Now, severe convective storms are not always simplistically driven by warm, moist air. Sometimes an air mass requires a disturbance that raises moist air to an altitude at which water vapor converts to liquid to initiate free convection. Other disturbances increase the dry air. So one such disturbance is caused by El Niño events, during which the regions of tropical convection shift across the Pacific Ocean, altering regions of dry high-pressure systems and wet low-pressure systems, as seen here. That pattern changes during La Niñas, which increase dry air masses in the western USA, which enhances convective energy potential for tornado weather. So future videos will examine the varying ways pressure systems change, result in naturally occurring extreme weather events that have sadly been weaponized to fearmonger a climate crisis. Up next, I will look at how pressure systems control the climate, part 2, deserts and droughts. And until then, embrace renowned scientist Thomas Huxley's advice that skepticism is the highest of duties and blind faith that one unpardonable sin. And if you appreciate the science clearly presented here, science rarely presented by mainstream media, then please give it a like, share it, or copy the video's URL and email it to friends. Subscribe to my channel to see all videos, or read my book, Landscapes and Cycles, An Environmentalist Journey to Climate Skepticism. Thank you.
All right. Thank you again, Jim. Just occurred to me that, well, I guess I'm going to pull an executive decision here. We will gladly send a free copy of your book, Landscapes and Cycles, as long as our supply lasts. And I think that we probably have about 40 or 50 copies available to anyone who requests it, as our way of saying thank you when you make a 100% tax-deductible donation to the Cornwall Alliance of literally any size. Now, this is not our normal offer for this month, So you're going to have to ask for it in a special way. Again, you'll go to cornwallalliance.org, click on the donate button, and as you fill out the donation form online, when you get to the comments field, write in special offer landscapes and cycles. Special offer landscapes and cycles. That will alert people that you encountered this offer during our live stream program this evening. And so if you'll do that anytime in the next, several months, as long as our supply has not run out, we'll be glad to send you a free copy of Jim's really excellent book, Landscapes and Cycles, An Environmentalist's Journey to Climate Skepticism. And skepticism,
Calvin,
I think,
can I add to
ahead.
this? I'll make my own decision here that if you run out, but more have been requested, I'll gladly donate whatever you need to match
my goodness,
those requests.
Thank you very much, Jim. Thank you
Glad
very
to
much.
help you out.
I was about to say, I consider skepticism to be one of the greatest Christian virtues. The Apostle Paul wrote in 1 Thessalonians 5:21, test all things, hold fast what is good. And that ought to characterize every Christian mind. We must not be driven about by every wind of doctrine, as Paul put it in 1 Timothy, but instead, we need to have sober minds. We need to be prepared to give an answer, a reason for the faith that we have, for the hope that we have, and to do so in a logical manner. In fact, 1 Peter says in 1 Peter 3:15, be always prepared to give a reason, an answer for the hope that lies in you. He uses the Greek word logos, from which we get the word logic. So I particularly appreciate Jim's skepticism, and I consider it to be something that Christians need to emulate. Skepticism doesn't need to be cynicism, shouldn't be cynicism. What it should be is a commitment to following the evidence where the evidence goes. And that's exactly what Jim has done. All right, so Jim, that second video talking about convective energy was a little technical in some ways.
Technical.
Can you sort of boil down the lesson there and how it applies to North American tornadoes to just a couple of minutes and put it in language that will really get across to non-meteorologists, non-scientists?
Well, basically what I was trying to show by delving into that research paper is what the science had been looking at is the increase. There's a decrease in rainfall. There's a decrease in thunderstorms. There's a decrease in this convective energy that allows these very devastating storms. It's just the opposite of what the narratives are saying should happen due to CO2 and climate change. So partly I wanted to delve into that. The other thing I wanted to make sure people understood the importance of dry air over humid air and why that gave it so much power. And for us in the Pacific, we were told right now we have a La Nina year. So you did have this drier air going across the mountains and interacting with that warm moisture coming up from the Gulf of Mexico. So that was part of another natural oscillation that was allowing this tornado to have such devastating effects. And still the Mayfield, Kentucky tornado has been rated somewhere between a 3 and a 4, meaning it's, and they base the strength of it partly on Doppler radar, but also by how much destruction happens. So they can combine some of that. And so it wasn't even the most extreme tornado we've seen. And just to kind of refer back to this increase in smaller tornadoes, these weak tornadoes, the zeros and the ones that increase the trend, they usually only last for about a minute. So it was very hard to detect them, and they had to have better radar, better storm spotters to add that number of tornadoes. And so when you saw this increase in the number of tornadoes, is really the detection of low violent tornadoes that only lasted for a minute. The more destructive ones will last for 15 minutes, half an hour, or longer. Um,
Mhm.
so those were always easily detected because of the damage and because of its longevity. But these real small tornadoes, which are, you know, they can cause some damage, but they were just detected by better detection levels. But that got pushed as, oh, this is due to climate change, and it's not. It's due to
Yeah.
detection. So I've again, I just wanted to push, and what I'm trying to do is combine, you know, good science and you know, sometimes what seems to me is fairly understandable, sometimes it's too technical, but
Yeah. Well,
read a
you know,
different video.
yeah, you pointed out that that the odds of tornadoes being observed changed from 30% to 75% over the period. What was it, from 1980 to 2002,
87
or what
to
was it?
2002. It was a very short period,
Yeah.
and but
So
that's
what
the
that
same
means
time they
is that
discovered.
out of
Go
every
ahead.
100 tornadoes in 1980, only 30 would even ever be noticed. Whereas by 2002, 75 would be noticed. Well, that's, you know, that's more than double. That's what, 2.5 times the number.
Yeah,
And so it's no
and that's
wonder that
all.
you're going to have an apparent upward trend in the number of tornadoes, but in fact, it's from better observational techniques, not from any increase in the actual number. The same thing is true of hurricanes, as we've had on this show a couple of times. Dr. Neil Frank, the former director of the National Hurricane Center, who pointed out,
Right.
for example, that in 2020, when everybody was making a big deal out of the fact that we had more named storms than ever before, he pointed out that a part of the reason for that is that we just simply observe more now than we did. But another part of the reason for that is that from about 2005 to about 2015 or so, the National Hurricane Center actually changed the criteria it uses to define a hurricane as distinct from a tropical depression or excuse me, a tropical storm. And that change in definition accounted for more than all of the difference between the previous greatest number observed back in 1930s, I believe it was 1933, and the number observed in 2020. So there are all kinds of ways in which uh, changes in technology as well as changes in definitions can affect our perception of the frequency and the intensity of storms. Um, Jim, we're pushing up close to the end of our time here. Uh, what what would you say to ordinary Americans, whether they're scientists or not scientists? What would you say to them about how, not what, but how to think when they encounter the almost nonstop news pushing the notion of dangerous to uh, catastrophic man-made global warming and its connection to whether it's floods or droughts, heat waves or cold snaps, tornadoes, hurricanes, wildfires? What would you say to people about how to think about these things?
Um, you know, that's difficult. I feel like I came to that by spending a lot of time out in nature, studying it, trying to
Mm.
understand why my wildlife was changing. And partly where I work too is the 49ers had devastated the Tahoe National Forest. You know, they cut down the trees for their mines and for their iron making and everything else. And this comeback is really been an amazing comeback. And I hear people say, oh, ecosystems are collapsing. Well, where I am, the ecosystems are doing better than they have been for a long time. And people aren't going to know that unless they're out in nature. And partly what I want to, as director of the field station, was to try to make all these environmental classes to get people outside, to get people to see it. And even if they spend a week or 2 weeks, so get a little more information, but you've got to be outside a lot more. You can't just rely on the internet and the news media. And what I'm hoping is, like this more technical video, that 2021 research also shows that when you really look at it, despite the definitions being changed, despite other detection things, that all this energy is not increasing. It's been decreasing, and it's really not quite happening. So if you can read some of those papers, if you can get some kind of technical knowledge, it would be helpful. And what I hope to do with the book or the videos is try to be a liaison between some of this more technical science and the lay person. And it's not always easy to make that bridge, but I'm going to keep trying. So.
Yeah, right. Okay, well, thank you very, very much for joining me this evening on From the Stacks. And I wish you a Merry Christmas and a Happy New Year. And I wish all of our viewers a Merry Christmas and a Happy New Year. For your information, so that you know in advance, we will not have the live stream the next 2 Tuesdays, the 28th or January the whatever it would be. We should return to the live stream the following Tuesday after that. But we're taking some Christmas vacation time, and then after that I have some business travel to do. And so we'll start up again the second Tuesday in January. That would be January 11. So thank you very much again for joining us. And again, I'll remind you that as our way of saying thank you, when you make a 100% tax deductible donation of literally any size to the Cornwall Alliance, we'd be delighted to send you a copy of this wonderful DVD documentary, The Riot and the Dance, Earth, narrated by Dr. Gordon Wilson, who's been my guest on the live stream a couple of times. And it's just beautiful. And unlike so many nature documentaries, instead of promoting belief in Darwinian naturalistic evolution, it really shows how the beauties of nature display the glory of God. So to request your free copy of The Riot and the Dance, just go to cornwallalliance.org, click on the donate button, and as you fill out the donation form, when you come to the comments field, write in promo code 21-12 or the title, The Riot and the Dance, and we'll be delighted to send you a free copy of The Riot and the Dance. Again, thank you so much for joining us this evening. Merry Christmas, and I pray that your Christmas will be one in which you focus on the Lord Jesus Christ and his incarnation and his perfect life in our place, and his sacrificial death also in our place, and his resurrection from the dead, showing that his sacrifice, his atoning sacrifice, was acceptable to pay the penalty for our sins, so that by faith in him we can be forgiven of our sins and reconciled with the holy God the Father through the work of the Holy Spirit. Thank you again for joining us. God bless you.